So a second type is going to be an inscribed angle. So what does an inscribed angle mean? Let me lead you into it. Have you ever seen string art?
Yeah.
Okay, and this one is, I know it doesn't show up real wonderful, but a circle of nails, and then they take different colored string and wrap it around certain nails, and it makes a certain design.
There's a bunch of triangles on
A lot of triangles in there, a lot of probably other shapes too. Another thing that makes this kind of design is a spirograph. Do you know what I'm talking about? They're gears, like round gears that you put your pin in and you draw the design as the gear goes around. Plastic gears usually, good. You know what I'm talking about? Okay, so a few of you know what I'm talking about. It's, you just make it go around in the circle and it makes designs like the string art would do also. Maybe you need to wish for one for Christmas, spirograph. I'm sure there's probably apps or that would do the same thing. We should try and find that sometime. So this makes a lot of inscribed angles. Now the inscribed angles are the ones that wrap around the nail. So when the angle is right on the nail in the outside edge, that's making an inscribed angle. So the actual definition, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. Draw yourself a picture. What would an inscribed angle look like? Have a circle. An angle whose vertex is on a circle and whose sides contain chords. The vertex is going to be here. What's a chord? Okay, intersects it twice. Actually, the chord ends right on the circle, but our angle is going to go beyond it. So this type of a picture is what we're looking at. There's chords that are on each side there. So the vertex is on the circle instead of type 1 where the vertex was in the center of the circle. All right, another term that goes along with this is what an intercepted arc is. The intercepted arc consists of endpoints that lie on the sides of the inscribed angle, and it's all the points on the circle between them. So let me highlight this point, and all the points on the circle between them. In blue, that's the intercepted arc related to that inscribed angle. So it's the arc inside it, intercepted arc. It ends right on the angle. Then a word that your book uses that I don't use too often, but it says a chord or an arc subtends an angle if its endpoints lie right on the angle. So if you have a chord, and that chord has the endpoints right on the angle, you would say this chord subtends the angle, or the arc subtends the angle. So kind of like it matches up, it has the same endpoints on the circle. So as far as understanding the vocabulary, let's see if this makes sense then. Angle DEF is an inscribed angle. Arc DF is the intercepted arc. And arc DF subtends angle DEF because it ends right on it. Okay. Thumbs up or down, makes sense out of that.
Wait, what is
Subtend means that this arc has endpoints right on that angle. So it matches up, the endpoints are right on the sides of the angle. Okay, so here's the theorem, how you get the measure of the inscribed angle. The measure of the inscribed angle is half of the measure of its intercepted arc. Now an inscribed angle, as we said, the vertex is on the circle. Why do they have three cases? It could look three different ways. Okay, the first look is where one side is a diameter of the circle. So it's kind of in half of the circle. Second case is where the center of the circle is inside the angle. And the last one is where the center of the circle is not inside the angle, it's outside the angle. But in all three cases, where's the vertex? On the circle. It's on the circle. Okay, your conclusion, how do you get its measure? The measure of the angle equals 1/2 the measure of the intercepted arc, the arc that's inside it. So we'll put that up here as our type 2 inscribed angle. Which would look like this. I'll put a 1 there. Actually, I'll put a 2. The measure of the second type is 1/2 the measure of the arc. All right, and if you don't know which arc, or if you're having trouble visualizing this, this is a good section to get a couple index cards. And if you're trying to find out what arc's inside, put the index cards on the side of the angle and it blocks out everything except what's inside the angle. That's a good way to focus when there's a lot of things going on there. So here's an example. Let's try and find the measure of angle PRU. Now we were doing arcs, you're gonna have to pay attention if it's arc or if it's angle. Okay? So angle PRU. How big is this angle? Not 118. Nope.
59.
59?
Oh.
Vertex is on the circle. This is the intercepted type, so it's 1/2 of 118. Okay, so 59 degrees, whoops. I did that without even noticing it. 59 degrees would be the angle on that one.
So why is it?
Okay, the vertex is on the circle, so it's type 2, the inscribed angle. The angle is 1/2 of the arc that's inside it. So what arc is inside that angle? 118, so it's divided by 2. Right, how about finding arc SP? So how many degrees is this arc? 54. So that time, you took 27 times 2 instead of divided by 2. Because the angle is 1/2 of the arc is bigger. If you forget which way, if you should multiply by 2 or divide by 2, if it's drawn somewhat to scale, you can probably tell. Would this be 13.5 degrees in relation to 360? You can kind of visually tell, no, it would be bigger. Okay, how about measure of angle DAE? Angle DAE. Is it right? Yes. 76 divided by 2. 38. And don't shout this one out. Measure of arc ADC. ADC. That goes a long ways around. A to D all the way to C. How many degrees is that whole angle? Is it 270? Morgan, can you explain? And why is he using the 135? That's angle B. So if I would block out everything else, you see the arc that I'm after is inside the angle he named. Vertex is on the circle, so this angle is 1/2 of the arc. So the arc was 135 times 2. That's the next type. Now there are some theorems that build on that. So this is one that's called a corollary. Remember what a corollary was? There were theorems, there were corollaries, there were postulates.
One that is the one that's always true.
Well, they are always true. Postulates, theorems, or corollaries are true. They've been proven true. In some cases, they're accepted true. It was a theorem that comes quickly or easily from another theorem. So you can get this from that last theorem just pretty quick and easy. I think I called it a baby theorem. It's not a big major thing all by itself. So this says if inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. Now this picture looks like kind of a mess. Well, let's see. Angle ACB. ACB is this angle. What arc is inside that red angle? Arc AB. Okay, now the blue one. Angle ADB. What arc is inside that angle? AB, the same one. And the green one, angle AEB. The arc inside there is AB also. So since all of those angles have the vertex on the circle, they're all half of the same arc. So does it make sense that they would all be the same degrees? If that arc is an 80-degree arc, angle C is 40, angle D is 40, angle E is 40. They're all half of 80. So that's what the conclusion is saying. Those angles, ACB, ADB, and AEB will all be the same degrees. Sometimes this is one that you don't notice right away. But if I focus on the arc and then see what angles come to the ends of it, you might notice that they're all half of the same thing. Got the notes? So here's an example. What arc is inside angle J? What arc is inside angle K? LM. So those two angles subtend the same arc. So they will be congruent, so set them equal to each other, yes. Does it feel warm in here to you?
Yeah. It's been
Okay, I'll see if I can get it to kick in or not.
Now that you mention it.
Yeah, it was okay earlier. Let's see if the air conditioner will kick in or not. They might have it on heat mode instead. Okay, so what are we getting for our angle? Don't stop when you find B. We're coming up with 10.5 for the angle. So B was how much? 3.5. So 10.5 was the angle. The arc would have been 21, but that's not what we were asking. Question on that sample? Okay, let's go back to the string art. Okay, click the front line for just a little bit, see if that helps that show up. Okay, find the measure of the inscribed angles and the intercepted arcs. Inscribed angle, where's the vertex? On the circle, okay. So actually on the circle. So any angle that has a vertex on the circle we're supposed to find. I know angle A is 60. Which one would be? Now C is not vertical to A. Vertical would be like these.
Not vertical, what is it? Alternate, yes.
Okay, are the lines parallel?
We're gonna hope so.
We're gonna hope so. No, that's not convincing.
They're not.
Keep looking. Okay, keep looking.
Oh, we know
Let other people. Okay. gonna try and catch some people that don't usually help me out. Tanan,
B and C is the same angle
angle B is the same angle as C,
because of the corollary.
okay? Understand? So do you know what angle B is?
43.
It's half of the arc that's inside it, which is 86. So yeah, 43 is half of 86. And then angle C, he said, is the same, half of 86. So 43. I know that doesn't show up very good as far as colors. Sorry.
What is that?
Okay, Kara.
Angle E is 86 because the vertical angles, because the arc is 86.
Okay, arc is 86,
So
so
then that's 86.
now why is this 86? Is it a central angle? No, it's not 86. That's gonna be our next type. We don't know how to find that one yet. Tina?
Would it be the corollary to C and B?
C and D,
C and B.
C and B, C and B.
Oh, no, never mind. It's plural.
Okay, the other angle we need to find is D. Trace the sides of D. Related to arc BC.
Oh, it'd be 86.
And BC's arc is also related to angle A. So if angle A is 60, arc BC is 120. And then angle D would be 60. Yes.
Can't you just figure out what?
Did you do like the triangle sum?
So now we could do angle E by triangle sum. So although E is not an intercepted angle or inscribed angle, we could find it. 60 plus 43 is 103, which means this would be 77. And vertical to it would be 77. And linear pair, 103, 103. So you're noticing that this angle was 103, but that arc was 86. And this angle is 103, and the arc inside it is 120. So we need to figure out what we're doing there. That's the next type. All right, okay, on the inscribed angles, the ones that were on the circle, you have to trace the sides. And like I said, a couple index cards could help you focus on what arc is inside a certain angle as you go through. If you need some, I probably have some index cards. Okay. How about this one? Find the measure of angle EDF. Trace the sides of angles. That's not the answer to the problem,
Well,
but that doesn't mean that you know how to do it. How did I get that answer?
I take 2x plus 3 is equal to 75 minus 2x because they share the same arc.
Okay.
Then you plug 18 back in for 2x plus 3.
And you should get what for the final answer?
41.
41 or 33 or
39.
39? 18 times 2 is 36 plus 3,
Oh.
sounds like
Oh,
39.
Oops, I minus back.
But yes, I accidentally put the answer too early in that slide. But understand how to do the problem, set those two equal because they both are intercepting arc EF. Correct. Okay. Another theorem deals with a semicircle. Now this one has the words if and only if. That's why I didn't put separately hypothesis, conclusion, because it's both. Could be the hypothesis one time and the conclusion the other. So that picture has an inscribed angle, actually 3 inscribed angles, but one of them is intercepting a semicircle. How do I know that there's a semicircle? Well, a diameter is going to cut the circle in half. So notice this right angle. If you go to the ends of that right angle, they will be the ends of a diameter in the circle. So this is saying if this is a 90-degree angle, since it's inscribed, the arc inside it is twice 90, which is 180. Is that 180 when it goes to the ends of the diameter? Yeah, the diameter cuts the circle in half. So you can start with the angle and get the arc. You can start with the arc and get the angle. It goes both ways. Okay? But a key would be a diameter. And that triangle, do you remember the chapter where we did like circumcenter, incenter, centroid? This was something that we created in that chapter. We had the circle on the outside and the triangle, all the corners of the triangle right on the shape. So it was a circumscribed circle. It was an inscribed triangle. Each angle is an inscribed angle. Okay, here's a problem related to that theorem. What do you need to notice? And think about it. You need to notice what?
Because in the,
Okay, there's a diameter. And if you go from the ends of the diameter, the angle formed is angle Z. So what should we know about angle Z? It's 90 degrees. So 5A plus 20 has to equal 90. Okay, work it. 5A plus 20 equals 90. Up here. A was 14, they're telling me. Did anyone research Thales of Miletus? As your mathematician? There's one. Last period, nobody claimed it. Do you remember coming across this theorem at all? Because this is, I'm pretty sure, one of his ideas. All right. And find Z. So you need to notice,
equals 9,
because,
that's where that's the angle that is formed by the diameter. So,
okay, when you go to the ends of the diameter on the inscribed angle. So that's 8Z minus 6 equals 90 again. So Z is 12. I got a slow transition on that slide. All right, suspense. All right, 12 was right. Okay, and a fourth one related to the inscribed angles. Now instead of a triangle, we have a quadrilateral inscribed in the circle. So every corner of the four-sided figure is on the circle. If a quadrilateral is inscribed in a circle, then, let's read what it says. Its opposite angles are supplementary. What's that mean?
means that they add together make one.
They add to be 180. So angle A and angle C will add up to be 180. Angles B and angle D will add up to 180. Let's throw some numbers up there and see if that really does work. Well, let's come up with the arc. Arc BCD. This whole arc in red, that goes quite a ways around the circle. 230 degrees. Okay, angle A subtends that arc,
It's 115.
so angle A is 115. Okay, now what is arc DB?
180.
Let me see your thinking. What's your thinking?
360 minus 230.
The whole circle is 360 degrees. He's subtracting 230 for the red one, so that leaves 130 for the green one. Correct. So if that arc is 130 and angle C inscribes it, 65, were those two opposite angles supplements?
Yes.
They add up to 180? Yes. Now my two arcs had to total 360, and each angle was half of their respective arc, so the total, half of 360 would be 180. And we could do the same thing, I know it'll look confusing, but from A around to C, let's say that's 200 degrees. So that means from A, this direction would be 160, which means angle D is. See what it goes to the ends of the 160. So this would be 80. And angle B goes to the ends of the 200. 100. So it does end up opposite angles are supplementary. Okay, so what are we going to make you do related to that one? Here's an example.
We had to find B.
And how did you find B?
We put J equal to G.
Okay,
Or
you put
supplementary.
J equal to G.
You add them to get one.
No, you add.
Okay, J, J's measure plus G's
Is 180.
equals 180, because it said they're supplementary. Okay, so I did that same thing. I got B to be 15. Okay, and when you substitute it in, the angles were, G was 70, J's 110, and 81, and 99. Okay, so opposite angles are supplementary, not congruent, supplementary. All right, with that grouping, with your row, find the measure of angle RUS, and then what A, right angle, and the triangle having a diameter.
We're gonna give it.
Okay, angle RUS,
It is
25 degrees.
divided by 2.
and A is
3.
3. How did we do the A part?
You, after you,
3
3 times 14 and times 12.
Minus 12
Yeah, and then equals 90.
equals 90. Okay, that has to do with the theorem that we had the triangle and the right angle. Or if you just trace the sides of angle T, R and U, those 2 points are the ends of a diameter, so that arc is 180 degrees. Half of 180 was 90. Okay, there's a little check of understanding. Let's go to the next type. I'm going to skip those. Okay, the 11.5, I said there were 4 types. We've accomplished 2 of them. We don't have as many examples on these last ones. Now, actually, this angle for theorem 11.5.1, notice the theorem says we've got a tangent and a secant. Tangent touches the circle how many points? 1. Secant. 2. If it were a chord, 2 again. It would just stop on the circle instead. A secant goes all the way through. So they've just got the rays to highlight the angle instead of drawing the whole lines and make it more confusing. So where's the vertex of this angle?
B.
And where's B? It's on the circle, just like the ones we were doing. But this is not an inscribed angle because it doesn't have 2 chords. It's like an inscribed angle that has turned far enough outside that whoop, one of those chords turns into a tangent. It's still that the angle is half of the arc that's inside it. Okay? The angle is half of the arc. It just looks a little different because notice the arc goes from the vertex of the angle around to just one side of the angle instead of between the two sides. So it just looks a little bit different. Vertex is still on the circle, it's still half of it. I'm gonna add that picture up here. So besides an inscribed angle, it could look like a tangent and a secant. That's still half of the arc. All right, ready for an example? Not quite.
Yeah, that's a little bit.
I thought it felt a little better. All right, here's an example. Find the measure of angle EFH. So trace angle EFH. Where's its vertex? F, which is on the circle. So the arc, or the angle is going to be half of the arc. What's the arc that's inside it? 130, so half of 130? 65.
So it's just like the ones.
It really is just like the ones we've been doing, but it turned and we have a tangent now instead of two chords. See that? Okay, how about find the measure of arc GF? GF. Glad you're giving each other time to think. Some ideas, Morgan? 116? Agree with her? Now let's have her talk us through. How'd you get there?
Well, I took 142 times 2 because the arc is twice the angle, and then I took the
Okay, now let me trace. So you're finding the arc that goes from here to here?
Yeah.
Okay, with her thinking, she took that times 2, so that red arc is 244. That wasn't the way I worked it, but let's hear her out.
And then I subtracted 244 from 360. And I got 116.
116 for that arc. Did she work okay?
It works exactly.
I think what she did is fine. Oh, what's a different way? Morgan?
You say 122, subtract 180, or 180 subtract 122,
To find?
angle G.
Okay, this angle over here, which we'd have to really use 3 letters, but they didn't give us one over here. So 180 minus 122 was 58?
Yeah.
Okay, so that angle's 58, then what?
Multiplied by 2.
Okay, to get the arc inside, we multiplied by 2, so 58 times 2 is 116. 58 times 2, 116. Anyone have another method? Go over that part? Okay, let me get rid of all my scribbles. Okay, so what Morgan, or second Morgan, did was use the linear pair. If this is 122, the linear pair would be 58 degrees. So they have to be supplements. Okay, now he looked at the angle, and the arc that's inside there is this one, the one we're after. And to get that, that's the type we're on right now, the arc is twice the angle. Okay, so 58 times 2. All right, let's try another picture. Measure of angle STU. STU. How are you doing on this one? How much? 58? Don't agree with her? Let's see what she was thinking. How did you go through? Okay, 83? Okay, 166 divided by 2. Correct. Okay, just hit the wrong button. Okay, and how about arc SR? Arc SR. Who haven't I heard from today much? Riley? 142? Okay, how much? She got 218? Let's see, Riley, you want to talk me through how you came up with yours?
I think you just do 71 times 2.
Okay, so you're using angle R, and the arc that's inside it is arc SR. So he's taking 71 times 2. 144.
Oh,
All right, that was correct. Yes. All right, and what do I have next? I have one more. Oh, new theorem. Okay, finally, type 3. This one doesn't have the vertex on the circle that we've been doing all period. So where's the vertex this time?
center of the circle.
Is it the center of the circle?
It's just in random point on the circle.
Okay, random point on the circle?
Well, inside.
In the circle.
Okay, in the circle, right. It's just a point that's on the inside of the circle. It could be at the center, but if it were, we'd probably use the central angle relationship. Now, this is formed by, it could be two secants, if we make those into lines. Could be two secants, the picture actually shows two chords. Intersect in the interior of the circle. Let's see what it says here. The measure of each angle formed is half the sum of the measures of its intercepted arcs. Half the sum of the intercepted arcs. Sum means add. So we're going to add two arcs. Which two? For angle 1, it says you're going to add arc AB, which is its intercepted arc, and arc CD, which is inside its vertical angle. So you're going to take those two arcs and really average together. So add them and divide by 2 to find the measure that's halfway between. And that's what the angle is. So let's put some numbers up here. 20 degrees, 80 degrees. What's angle 1? 80 plus 20 divided by 2, 50 degrees. And this angle is 50 degrees also. The vertical angle would be the same. You could go the angle above it, angle AEC, 130, and the one below it, 130 also. So you can find more than just one thing in this. Okay, let's have you find measure of angle A. Get it pumped up into your brain. All right. All right, the answer to that last one was 126. I think all your rows eventually decided on that. See, that one's about the same. How about this one? Find angle R and N. You'll be finding the small angle in this picture. Well, she was just asking. Well, R. Okay, which angle is that? Okay, 3 letters.
The R and
Okay, was how much? 158.
and since it's like the lines are
Shh.
like linear pairs,
Okay.
then I use that to find the smaller, the R and
Right. So the linear pair. So she's then doing 180 minus 158.
yeah, I got
22 degrees. Okay, how many rows got that right? Did we eventually get everyone figured out? Okay. All right, yeah, I heard the row telling you to subtract from 180, that linear pair part. Okay, where's the vertex of those last type? The ones that we just got done? It's inside the circle. Okay, last type, 4,
Outside the circle.
angle vertex is outside the circle. I have to catch up on the board here. Okay, so subtract the two arcs and divide by 2. So let's put some numbers on these pictures that you took a little bit of time to draw. Okay, this first one looks like about 140 degrees for the big arc. The small arc is about 60. So what's the angle? I don't think so. 140 minus 60, which is 80 divided by 2, 40. So notice it's not half of the small arc, it's not half of the big arc. It's half of their difference. A second picture has two tangents. I'm going to tell you the big arc, EHG, looks like it's about 260 degrees. What's the angle? What's the other arc?
100.
How's she getting 100? All right, 360 minus 260, because since this is two tangents, there's only two arcs that the angle's making. So that and the one inside here have to add up to 360 total for the whole circle. So 260 minus 100, 160 divided by 2, 80 degrees for the angle. And this last one, there's 4 arcs, so I'll just give you, this one looks like about a 90 and a 20. So the angle, 90 minus 20 divided by 2, 35 degrees. Okay, so it can look different ways depending upon if they're secants or tangents. Watch out for the tangent where the two arcs total 360. Sometimes they'll throw a radius or a diameter, I guess I should say, a diameter into these. 40. Okay, 40. And the second one was 63.
Even
Okay.
though it doesn't make sense how the bigger angle is 7. The physical different scale.
The what?
Like, because where it says 7, and then those, how this gets smaller, it's.
Okay, 7 is this little arc right here,
Oh.
7 degrees. And the angle outside it is a 40-degree angle. Yeah, it's different things that you're doing. Okay, and one more for you and your partner group to figure out. What is X? What's the missing arc?
Good.
Whisper to each other so you don't tell every row. Okay, what do we think?
33.
Listen. 33, Tanan told me 33 a little while ago. Okay, that one is just kind of weird when you're solving it. Now what did I do to go from, well, this was my original equation, arc minus arc, half of it gives you the angle. So what did I do then to get my next line? I multiplied each side by 2, which got rid of the 1/2 and doubled this angle. Now here, this is kind of weird. Usually we have x minus 83, but this is 83 minus x.
So we have the minus 53.
So I don't think I would subtract 50 from each side because then everything's on one side of the equation. Maybe you would subtract the 83.
But then it equals out because the x is negative. So then you have to divide by -1.
Correct.
You get a positive.
And so you get a positive 33 for the x.
Would it work too if you subtracted, added x?
Yeah, you could add x from to each side and subtract 50. That could work also. Okay, on the bottom of your notes, there's a summary. Now, my chart that I'm going to show you doesn't have the first one. So first type was the central angle. Okay, so draw yourself in your chart there at the bottom. It says the vertex is supposed to be the center of the circle because the angle is equal to the arc. Okay, so type 1, doesn't it say The location of the vertex of the angle is the center of the circle, and the measure of the angles is equal to the intercepted arc. The summary chart at the bottom there, well, read through what it says. Clicking ahead. Now, my chart up here does not have all four. It just had the last three. So add to what my notes are here, the central angle. So your first type was the central angle, your diagram, the vertex was the center of the circle. Okay, that's type 1. Okay, type 2, the vertex is on the circle. The angle is half the measure of the arc. The third type was where the vertex was inside the angle. You had to add the two arcs and take half of it. And the fourth type was the ones where the vertex is outside the circle. You have to subtract the two arcs and take half of it. I do have that on the wall. See what, above the fire thing? Type 1, 2, 3, 4. Do you know what those mean or what types they are? That would help you know what to do. All right, let me give you the problems that you're gonna work on, and you've got some time to get a start on those before you leave.
You know the worst part about getting your stuff done, you have to write it all down.
You have to write